Where's everybody? Look, don't want to be on camera. Where's this streaming now?
This one.
Oh, okay. Cool.
Okay, good afternoon and welcome to Harmful Algal Blooms 101, Bloom Basics and Public Health Response. My name is Keith Skiles, I'm Director of the Shellfish Division in the Health Department, and I will try to facilitate the training. Go ahead and do this. Okay, and so as an introduction, Virginia is an incredibly diverse state. We're very fortunate to have so many things to enjoy, from playing in water of our lakes and streams and estuaries to enjoying catching and dining on our bounty of fish, crab, and shellfish. As public health specialists, we are aware of many of the dangers that natural waterways can present. Risks of drowning, injury, and pathogens which may be present are concerns we work hard to make the public aware of, and are especially as air and water temperature rise. So today's training was developed to provide VDH staff greater awareness of one of these dangers, which is the potential for exposure to harmful algal blooms in our waterways. Harmful algal blooms, or HABs for short, can impact public health when people become exposed to blooms through recreation in waters with a bloom or consuming fish or shellfish from a water body experiencing bloom. HABs can also impact drinking water reservoirs. So today's training aims to ensure that VDH staff are prepared with the basic knowledge and understanding necessary in their respective roles to participate and provide support during HAB investigations which may occur. Here's our presentation. So is everyone seeing a camera or a presentation? There we go. So our target audience for this training includes epidemiology and nursing staff, as environmental health staff, and public information officers. And we consider these staff to be priority staff serving as boots on the ground during harmful algal bloom events. This training is being recorded and will be posted online, and we encourage review of the training video by anyone who may be involved in the HAB response, whether it be at the local, regional, or the state level. So the purpose of this training is to educate priority staff on harmful algal blooms, regional district staff roles, and responsibilities during the bloom event, issuing recreational advisories for HABs, sampling and analyzing for HABs, and services provided by the Virginia Harmful Algal Bloom Task Force. And our learning objectives are, at the conclusion of this training, that we will be able to explain everyone's role during a HAB event, to identify the characteristics of algal blooms and the health effects which are possible, to describe best practices to avoid exposure to blooms or what to do if exposed, and to explain to the public where to find information on blooms and how to report blooms or fish kills. So we have a full agenda today, and we'll be trying to observe a strict schedule in order to wrap up by 4 p.m. So our training will be delivered in 4 sessions. In session 1, we'll provide an overview of HABs and the HAB task force. In session 2, we will focus on HABs for epidemiology and nursing staff. In session 3, we'll focus on HABs for environmental health staff. And in session 4, we'll review HAB resources and summarize our learning for the day. We have several speakers on hand to share their experience responding to and investigating HABs, and I'll introduce them to you during our training sessions. Question and answer opportunities are offered following each session, so please hold your questions until that time. We'll open the floor to the audience and unmute the line to ask for questions. And please remember to put your mic back on mute. And we've built in a 5-minute break between sessions 3 and 4, right around 2:30 p.m. following the session 3 Q&A. We have a few housekeeping items to talk about as well. So first, please, if you haven't already, register and train, course 107-0588. And please submit a course survey and train. Your feedback is important to us. The Polycon is being recorded and will be posted at www.harmfulalgalbloomva.com. And please keep your microphones on mute unless asking for a question during our Q&A sessions. And please do not interrupt the training or technical issues. Please email Richard Watson at richardwatson.vdh.virginia.gov or 804-864-7179, and he will be able to help you if you have Polycon issues. With that, I'd like to introduce Dr. Todd Edgerton, who will be presenting Phytoplankton 101, an overview of freshwater and marine algae and HABs in Virginia. So Todd is a supervisor with the VDH Division of Shellfish Sanitation Marine Science Branch, which monitors water quality and conducts environmental or enhanced pollution assessments in the state's shellfish growing areas, and oversees the Shellfish Marine Biotoxin Control Plan. Dr. Edgerton has over 15 years of research experience with Virginia algal blooms and directs the Phytoplankton Analysis Laboratory at Old Dominion University, and is a member of the Virginia Harmful Algal Bloom Task Force.
Thank you. Thank you. So the talk I'm going to start with today should sort of lay the foundation for what we're going to be talking about the rest of the day. So it should introduce us to the idea of algae, algal blooms, etc., that we can build off of for the rest of the day. We'll start with just some definitions. We're going to talk about what do we mean by algae, what do we mean by algal blooms, for those of us that maybe haven't worked as much with algae in the past. And then talk more specifically about what is a harmful algal bloom, what is a HAB, in terms of describing what they are in terms of general characteristics and then causes of these blooms. And then introduce some of the consequences, although we'll spend more time on that this afternoon, looking at the human health impacts. Talk a little bit about the natural resource impacts first. And then briefly touch on some of the HAB prevalence in Virginia, both on the coastal and freshwater side. So we'll start with getting some definitions out of the way. Algae, we probably all have heard of algae. We might not necessarily know exactly what it is. It's really a functional definition. These are a group of organisms, not really a coherent phylogenetic group like mammals or birds or even land plants, but they're a group of things that share similar characteristics. And they include not just eukaryotic algae, but also bacteria. So we have blue-green algae, cyanobacteria are also considered algae for this purpose. So in terms of what is that functional definition, these are the general features. And there's going to be some exceptions, but for the most part, we're talking about things that are aquatic. These are in the water. They're photosynthetic. They use chlorophyll and other pigments to produce energy. They lack a vascular system, so there's no roots or shoots. These aren't plants. Wide variety of forms. They can be unicellular, colonial, filamentous. In fact, they're incredibly diverse. There's an estimated over 73,000 species of algae in the planet. And when we say phytoplankton, these are the pelagic, again, in the water, microscopic algae. So this is opposed to macroscopic algae. These aren't seaweeds, a little bit different, and compared to terrestrial and paraphytic forms. So the algae that grows on the side of your shed, or stuff that grows on rocks, etc. Those are other types of algae. I wanted to put this slide in, talking about the importance of algae to the planet. We're going to spend really the bulk of the afternoon talking about harmful algae, but I wanted to just sort of stress briefly that algae are very important to the environment. About half of the major primary production on this planet comes from algae. Oceanic algae provide about half of the global oxygen that's used and produced on the planet. So they're very important, especially to aquatic systems on the global scale. We use them on research models. They're a great indicator of environmental change. We work with part of the Chesapeake Bay Monitoring Program. We've used algae for decades to monitor environmental change. It's also used, we've done research on food interactions, biodiversity studies, and there's even a lot of work looking at algae as biofuels. So there's a lot of very important things that do use algae. And of course, the reason we're here today is we're talking about the potential negative impacts that some algae might have on natural resources and human health. So again, algae provide the basis of aquatic food webs. We've probably all seen some sort of figure like this. We have phytoplankton or algae on the bottom here, making up the base of these aquatic food webs. Then they're fed on by larger and larger animals, zooplankton or fish larvae, larger fish, etc. On the benthic side, we have algae that are fed on by oysters and other filter feeders. And then these can make their way up to larger and larger predators, including, of course, people as well. And it's the same pathway, which is why we're concerned about these from a health standpoint. Algae are fed on by other organisms, including organisms that we eat, like mollusks, oysters, clams, scallops, etc. A lot of you probably are still thinking, algae, this is the stuff in my pool. Well, I guess hopefully, if nothing else today, we'll stress that all algae are not the same. In fact, we've identified over 1,500 different species of algae in Chesapeake Bay alone. So we could spend all day just going on over all the different types of algae, but we'll do that relatively briefly here. Just introduce the major groups that are found within Virginia. So these 5 groups represent over 95% of all the algal species that we see in Virginia. We'll start with the diatoms. These are probably the most dominant type of algae within our region, also worldwide. Diatoms are unique in that they have a silica frustule. It's like an exoskeleton. They're very fast growing. They do include, for our purposes, some toxic species, but are in general very, very widespread throughout Virginia and Chesapeake Bay and the rest of the ocean as well. Dinoflagellates, probably my favorite group. I've worked a lot with dinoflagellates. These are modal species. They have flagella. They can swim, generally unicellular. They have very complex life histories. You'll see these in the benthos as well as the water column. These are in coral reefs. Dinoflagellates are the photosynthetic component, zooxanthellae within corals. And in terms of regional importance, these are the major bloom formers and major toxin species that we see in our coastal waters, including Chesapeake Bay. Cryptomonads, not really of a concern in terms of toxic or harmful impact. They do form a major part of the phytoplankton community. On the other side, cyanobacteria, so our blue-green algae, those are prokaryotic. They're bacteria. They can produce, some of that can produce fixed nitrogen, so they're very important to the environment. They have a wide variety of forms, colonial, filamentous, unicellular. And these are our most common freshwater harmful algal bloom species. So a lot of these that we're concerned with on the freshwater side are cyanobacteria. The other dominant form in freshwater are chlorophytes. Some of them may appear similar, but these are not toxic. So another very common, important species on the freshwater side. So this represents, again, a little bit of the diversity of about 95% of all the different types of algal forms in our region. So what about blooms? So we've heard of blooms, but we'll talk about a little bit about some of the general characteristics. So algal blooms are natural phenomena. They exist throughout the planet in freshwater habitats, oceans, estuaries, basically everywhere. these are events that occur. So these are episodic. They can last from a few days to several months, and they have some sort of symptom associated with them. Extraordinary, in fact, in the fact that they're different than what you would describe as the normal condition of that water body. So that symptom could just be a change in color, it could be an odor, it could lead to dissolved oxygen, or other impacts like we'll talk more about here. Often these blooms are referred to based on the color that they impart on the water column. So you've heard of red tides or brown tides, mahogany tides. Those are all different descriptions of algal blooms based on the different pigmentation that those species might have. What causes algal blooms? So in general, we're talking about one or two species that have special environmental conditions that favor those species. So something is brought into the environment that favors the development of that one species. Classically, we think of nutrient additions, fertilizer runoff, etc. Warmer temperatures in general. Most blooms occur during the summer, so water temperatures above 25, or in Hampton Roads above 28 even, are associated with algal blooms. Mixing of water column, changes in salinity, all of these and combinations of them can lead to different forms of algal blooms. On the flip side, sort of the opposite is what leads these blooms to die off or disrupt. Most blooms will dissipate within a few weeks or maybe even a few months in some cases. Generally, it's the opposite sort of conditions. So lower temperatures, storms may come in. Storms can cause algal blooms by washing in nutrients. They can also disrupt blooms and lead to the termination. Nutrients that have been brought in can be reduced by the bloom using it up. And then all of this grazing that's going on, that can graze down algal blooms as well. Different algal species competing and even viruses can also lead to the demise of certain algal blooms. So now we're getting to some of Virginia blooms. So what do blooms look like? Well, they can take obviously many different appearances. They can form mats. Algae can form mats that either float on the surface. So we have some pictures here on the right of floating algal mats in the bottom right, or those mats might be formed below the surface on the bottom of the lake. So this is a bloom from Virginia a couple of years back of algal blooms below the surface. Some don't form mats. Some will just form uniform discoloration across the water body. Often in freshwater that's green. You can see some freshwater blooms here. It's not always green. So in the middle we have a picture of a red bloom. This is from last year near Richmond. This is a bloom of a red algae, of a Euglena sanguinea, has a red pigmentation. Sometimes there'll be a really thick scum. This is a really dense cyanobacteria bloom of Microcystis. This is not from Virginia. This is in Guatemala, very heavily polluted lake. On marine waters, often the dominant dinoflagellate or the dominant algal species do not have a green pigmentation. The dinoflagellates have a red or brown pigmentation. So we'll see more of this color here. These are blooms from the Lafayette River and the York River dinoflagellates. And the pigments can even be bioluminescent. So some dinoflagellates can produce a bioluminescent pigment here, and this is an Alexander monollatum bloom. At night, you can see this bioluminescence in the Elizabeth River from a couple of years ago. So that's what algal blooms sort of look like on the surface. At the scale of algae, they can look a little bit different. So you want to think about what the algal community is in a non-bloom status. So we'll have lots of different algae all competing at relatively low densities. Here's a lot of different diatoms and dinoflagellates. You can see that we have a combination of diatoms, dinoflagellates, and other species. During a bloom, though, we'll have a single species really take over and dominate that community. So this, during a bloom, can take up to 80, 90, even close to 100% of the total biomass by a single species. This is Cotyledonium polycricoides that we'll talk more about in the afternoon. And this is what that same bloom looks like from overhead. So when we have some good aerial footage of these blooms, you can see they form dense banding around in the Elizabeth River here next to Old Dominion University. So we're talking about blooms. What about harmful algal blooms? So HABs are harmful algal bloom, and we've talked about having a symptom. So in this case, the symptom is something that we would consider harmful or deleterious to the environment. We do see these nuisance blooms, as you could call them, basically in our region in lower Chesapeake Bay, in most of the summer and fall months. And as these blooms decompose, bacterial decomposition can lead to a reduction in dissolved oxygen in the water. So when you hear about the Chesapeake Bay dead zones, that's what we're talking about here. This is the decomposition of algal biomass, especially in these deep basins within the Chesapeake Bay. Just by the very nature of having a lot of particles in the water, These blooms can clog gill tissue, so fish and invertebrates, their gills can be clogged. Blooms can cause odors, they can discolor water. Again, they can shade out seagrass beds, so underwater seagrass beds can be shaded out by harmful algal blooms. And most of these blooms, these high biomass blooms, are produced by dinoflagellates in our estuaries and in freshwater, predominantly by cyanobacteria. So what about toxin-producing HABs? These are relatively rare in the sense that we talked about over 73,000 species of algae. Around 300 or so are thought to form blooms, and about 100 or so are known to produce toxins. So these toxins can cause, when they present, serious impacts leading to fish kills. Usually, most visibly, these blooms occur near agriculture or other animals. They can lead to pet and livestock or wildlife mortalities if animals are able to drink the water or get the toxin in their system. And we do have harmful effects to humans. This includes potential shellfish contamination, drinking water contamination, recreational contact. So harmful algal blooms are found throughout the world. This is just a brief distribution of different harmful algal bloom species. We have Alexandrium here, and Pseudonytzia and Dinophysis. You can see that there's distributed throughout the world here, as well as within the United States. So we have marine and coastal species affecting both our Atlantic coast, Pacific, and Gulf, as well as freshwater blooms affecting every single state in the nation. We had some major bloom events in the last 3 years. 2014, I'm sure a lot of you are familiar with the cyanobacteria bloom in Lake Erie that left over 400,000 people in Toledo without safe drinking water. 2015, we had the largest marine bloom of its type along the entire Pacific coast that led to the entire shellfish harvest being shut down in 2015 along the entire coast. And in 2016, we had a major cyanobacteria bloom in Florida. There's a lot of pictures showing coasts and beaches being completely clogged by algal blooms. And we have these same species, many of these same species here in Virginia. So we do have harmful algal bloom species present in Virginia. We'll talk a little bit more about these later, both on the marine side, where we see blooms, routine seasonal blooms, dinoflagellates in the lower bay annually. These can lead to fish kills and oxidous shading. But importantly, I'll point out that there has been no harmful algal bloom related human illnesses from Virginia shellfish, as well as also none from Maryland or Delaware, speaking with our colleagues there. On the freshwater side, again, we do have the same species that are seen at the national and global level that can produce toxins. And in a relatively recent survey of Virginia lakes and ponds, we've seen that these species are present in just about half of the ponds and lakes that we've looked at, providing that there's a lot of potential for toxin production on the freshwater side as well. So in summary, quickly, hopefully we'll point out that algae are an important natural resource to common aquatic systems, component to aquatic systems. The majority of algal blooms are brief and relatively restricted in area, that not all algal blooms do represent a health concern, but that non-toxic blooms can still impact natural resources through some of the ways I mentioned, anoxia, shading, clogging gill tissues, etc. And on the harmful algal bloom summary, although relatively few in number, toxin-producing algae are established in our coastal and freshwaters throughout Virginia. Toxic harmful algal blooms do pose potential threats to shellfish contamination, drinking and recreational water contamination, and natural resource impacts. And that the ongoing statewide collaborative programs that you'll hear about in a second are necessary to monitor algae, toxins, and potential health impacts. Thank you very much.
Okay, thanks, Todd. You go to the next presentation. I remind everyone that we'll take questions after the end of the session. So for now, we're going to go to Margaret Smigo. She's going to present on Virginia's HAB Task Force Background, Roles, and Response Plan. And Margaret is the Waterborne Hazards Control Program Coordinator within the VDH Office of Epidemiology's Division of Environmental Epidemiology, where she serves as the co-lead of Virginia Harmful Algal Bloom Task Force with the VDH Division of Shellfish Sanitation, the VDH Office of Drinking Water, and the Department of Environmental Quality. She is the HAB Task Force's coordinator and consults with districts during surveillance and response activities where recreational uses meet. Margaret?
Thanks, Keith. So if you haven't met or spoken with me, it's probably because you haven't had a harmful algal bloom in your health district yet. Dun, dun, dun. So I want to go a brief overview, rundown of topics in this presentation, include a background of the HAB task force and the services it provides, followed by a summary of the HAB task force response plan, featuring task force member agency roles and responsibilities, and most importantly, the roles and responsibilities of the local health district staff. So first, a background on the HAB task force. There are 5 primary support members in the task force: the Department of Environmental Quality, the Virginia Marine Resources Commission, Old Dominion University, Virginia Institute for Marine Science, and the Virginia Department of Health. There are a handful of secondary support agencies serving the task force as well, including the Department of Conservation and Recreation and the Department of Game and Inland Fisheries. The HAB task force was assembled in the 1990s due to concerns related to Syria. Funding was provided via CDC grants to help Atlantic and Gulf states establish surveillance and monitoring programs. The focus of monitoring were coastal areas. Around 2010, the concern for Pfiesteria subsided as states were not finding Pfiesteria in significant numbers, if at all, and federal funding was discontinued. The task force was successfully able to petition the government for additional state funding, which kept the program afloat. Yuck, yuck. Over time, the needs for HAB surveillance and response have changed. These changes have caused task force members to reconsider priorities, as well as the need for additional funding to support the rising needs. In particular, for freshwater blooms due to cyanobacteria species, which impact our recreational water uses and drinking water reservoirs. There are also marine species of concern, such as Alexandrium, Dinophysis, Carolodinium species. These are species which pose a threat to public health, as well as the booming aquaculture business along Virginia's coastline. So now moving forward into HAB task force services provided, we have here a map of marine and brackish waters to give you an idea of the amount of surveillance that has been conducted. This is a 2016 surveillance site map. The DSS sites are in orange. DEQ, Chesapeake Bay monitoring sites are in green, and the bloom response sites are in red. VDH, DSS, and ODU alone collected approximately 650 samples. This map depicts the freshwater surveillance and bloom response sites in 2016. Freshwater monitoring began as a collaborative effort of DEE and ODU back in 2010, and each year about a dozen sites have been sampled and evaluated for HAB species. Now, by comparison, freshwater monitoring is far less impressive. This is primarily due to funding and lab capacity. Our program is not funded adequately to support statewide freshwater HAB surveillance at this time. So of note, the task force prioritizes response efforts on public bodies of water and public access points. There are many private water bodies in Virginia. We frequently get requests from private landowners to assist them with algal blooms. We evaluate those situations to determine if there is any public health impact, and we will also work with the local health district to determine what their needs are, what their concerns are. But we will often refer private landowners to private lake management firms to help them with their algae issues. So continuing on with services, so once you have your sample collected, it gets sent to the lab, and once it arrives at the lab will conduct phytoplankton identification by genera or species, and they enumerate each type. They may also do toxin assays. Most of our toxin assays are done by ELISA, or enzyme-linked immunosorbent assays. Some counts will either be done visually or by PCR. So So how do we report information out of the task force? We do that using our algal bloom surveillance map. Once we get our information from our lab partners, we'll enter the results onto our map. When we have blooms of significance, we will also create feature web pages. This provides a site that's accessible to local health districts, the public, when they're looking for information about the bloom. We also distribute a HAB digest seasonally to our task force members on a monthly basis to keep everyone in the loop. And we host an annual HAB task force meeting to summarize our work each year. Other ways that we report out, or we share our subject matter expertise, is we've developed signage to help with public health messaging. We have template press releases. We create FAQs, oftentimes for specific events. We have fact sheets, and we have brochures, and we'll even help you do your message maps. So how do we get information into the HAB task force? There are two primary methods for reporting information related to bloom events or fish kills. The first is the HAB hotline, which is monitored 24/7 by DEE staff. This is for HAB-related human health effects. And then we have a new online HAB report form available on our website, harmfulalgalblooms.com, where you can report bloom and fish kill information. This report form is really great in that it allows anyone, including VDH staff, to quickly submit a report online, even if it's on behalf of someone else. A submitted form initiates an email to primary HAB response task force members, and it sends the original completant, providing you put their email in, a thank you email with messaging about how to prevent exposure to blooms and links to our website. So it's a great communication tool for task force members as well. So now moving on to guidance. The task force updated its HAB response plan this year. Within it, we organized our efforts within 4 objectives. For the purposes of this presentation, we're going to focus on Objective 3, which is identify primary support members and their roles and responsibilities. We will touch on the other objectives from our response plan noted here within presentations given later today. And so moving on into HAB task force agency roles and responsibilities. First up is the Department of Environmental Quality. They co-lead the HAB task force with VDH. They collect samples, and they also collect other environmental data during HAB events and respond to fish kills. They may also transport fish specimens to our VIMS lab. Historically, their service was limited to coastal areas because that's where the task force started out. But it has expanded to service statewide more recently with the prevalence of freshwater blooms occurring. But what I'd like for districts to kind of keep in mind is that their offices are located regionally. So they are much more spread out than a lot of our health district staffs are. So DEQ may have to drive really long distances to get to a bloom site. Moving on to our laboratories, the Virginia Institute for Marine Science and Old Dominion University. They collect our marine, they not only analyze samples, but they will also collect water samples. They provide taxonomic identification and enumeration of HABs and fresh and marine samples. They run our toxin assays. They develop assay methods and conduct research. There are phytoplankton and HAB experts. It is important to note that both of our labs are located along the Tidewater area in Virginia, down in Gloucester Point for VIMS and Norfolk for ODU. Now, logistically, this does pose difficulty during the summer, especially when it comes to delivering samples. It can also take much longer to get samples from the western side of the state to our labs from other like central and Tidewater areas where it might be more convenient to just drive them, for example. The Virginia Marine Resources Commission serves as the enforcement agency for marine water closures and is also a trusted resource of information for watermen and boaters. They're an agency who is helpful for public messaging to those groups. So, Office of Environmental Health Services, Division of Shellfish Sanitation, They manage our shellfish growing areas. They conduct surveillance. They issue closures to protect closures on growing areas to protect human health. These folks do a lot of sampling and a lot of analysis. They also have a biotoxin contingency plan, which informs them of how they would test shellfish during a HAB event that impacts a growing area. Another VDH partner is the Office of Drinking Water. The Office of Drinking Water works with public utilities to help them in the development of source water protection plans. They have also developed their own draft HAB response plan for drinking water. They work with public utilities during HAB events and provide guidance for adjusting treatment in the plant. And they can work with public utilities to issue drinking water advisories based on sample results. So Office of Epi, Division of Environmental Epidemiology, I like to think of us as the middleman for anyone who might be involved with a HAB response in Virginia. And we've worked really hard over the last year to ensure that VDH is notified of algal activity. We feel that if we know about an event, we can share that information with our task force partners as well as the local health district staff, even if it's only for situational awareness. And we coordinate the task force through collaborative meetings with our partners in conjunction with our co-lead, who is DEQ. We develop service agreements with our partners, update the website, HAB maps, store the HAB data. We work with local health departments, and we collect samples as well. So now on to regional and local staff roles and responsibilities. These are probably the most important to you. The roles of regional and local staff specifically are EPI and EPI nurses, environmental health specialists, and public information officers. I think if VDH-DEE had a motto, it would be all responses local. So epidemiologists and nursing staff, they conduct human illness surveillance and epi interviews for suspected HAB-related illness. They submit HAB health screening forms to DEE, and they coordinate outreach for HAB-associated event information with medical providers, hospitals, poison control centers, and others as necessary. Environmental health staff, they support HAB investigations by facilitating sample collection when requested. They coordinate with health directors, PIOs, issue and lift recreational advisories, and post signage. And they coordinate outreach and press release information for HAB-associated events with PIOs and DE. Public information officers, they support HAB investigations by coordinating consistent messaging to the public. They work on press releases for advisories, and they coordinate media interviews with staff and subject matter experts as necessary. The majority of information to support PIOs is found in our toolkit, which is also our resource list, which we'll review in session 4. A special thank you to all of our task force partners today. And I think it's time for question session 1 time.
Okay. Does anyone out there have questions for our speakers in session 1? Everybody at once? While everybody else is thinking of theirs, I'll ask one for Todd. Are algal blooms increasing or decreasing in Virginia?
Do you want me to come up there? Or?
Sure.
No, I would say in general, yes. We do see more dinoflagellate blooms, especially within the last 10 years. We've been seeing both through the work with VDH as well as ODU and VIMS have seen more dinoflagellate blooms. Definitely since 2007. On the freshwater side, we probably have seen more as well. There is probably a little bit larger effort now, like Margaret's been saying, and there's more capacity for toxin testing. But in general, I would say the trend is definitely increasing in terms of number of blooms.
Any idea why?
There's a lot of hypotheses. Global warming is always thrown out there. We do have warmer water temperatures. That seems to really impact it. There's ongoing eutrophication. I know we are seeing some reductions in some area, but it does seem to be linked to increased nutrients, and those can even be due to storms, where we've had a legacy of nutrients in the sediment that can be stirred up by tropical storms and other events.
Any other questions? No. Well, since we have a little more time, then I'll ask one of Margaret. What makes how would you know if a bloom is harmful or not?
So a bloom may be harmful from a public health standpoint if it poses or has the potential to pose a human health concern. And so in the simplest of terms, if it could or has the possibility to produce toxins which directly or indirectly might endanger public health, investigating that bloom and the potential impacts to public health would be a priority. This would include impacts to food and drinking water sources, as well as to our natural resources, which would include recreational impacts. To determine if a bloom is quote-unquote harmful, we collect a sample to look for potentially harmful species present and see what concentration they're at. When there are species at elevated concentrations, the toxin analysis might be conducted by the lab. We can compare those results with existing guidance, and because research in HABs is somewhat of an emerging science, the thresholds for all species and toxins are not fully understood. So that's just something to kind of keep in mind, especially with cyanobacteria.
Thanks. Probably don't do that. So any other questions for session 1 speakers? Then for session 2, Kim, do you have a question out there? No? Okay. So our first speaker in session 2 is Dr. Kim Reeks, who's presenting marine HABs and human health. And Kim is the chair as well as professor for aquatic sciences with the Virginia Institute of Marine Science, who has studied HABs in the Mid-Atlantic for 20 years. The main objective of her research program is the genetic characterization and analysis of the impacts of HAB species and other waterborne pathogens, including organisms harmful to humans and aquaculture shellfish. Her many peer-reviewed publications are related to the ecology, genetics, molecular phylogenetics, pathogenicity, impacts, and transmission of harmful aquatic microbes. So with that, Kim, you're queued up.
Okay, well, hopefully you can hear me. Thank you, Keith. Let me know if there's any problems, but I hope you can see my presentation here. Today, I think they've already gone over this. The routes of exposure for human health exposure is typically by consumption, and often it's shellfish, but there can be some finfish, and we'll talk a little bit about a finfish exposure today. Accidental ingestion while recreating, swimming, and for freshwater, drinking water can be an issue, as we talked about for Lake Erie it was. For some of the blooms here in Virginia, one of the things we're watching carefully is dermal exposure, because we've had some allergy-type responses reported, very low incidence with workers exposed. Toxins rarely can be absorbed through the skin, and inhalation. This has often been a problem, particularly you might hear about this in Florida, where on the beaches there's some aerosolization of Perennia brevis and produces a toxin that can be inhaled, so that can be a problem as well. The bioaccumulation in edible fish tissues might happen also in freshwater, but there's really not much study done on that yet, so that's an area of ongoing research. You often might hear about these particular syndromes: paralytic shellfish poisoning, amnesic shellfish poisoning, diuretic, and they're caused by, Todd talked about the different species, dinoflagellates, diatoms, can cause these various syndromes when they are accumulated, often in shellfish or with ciguatera poisoning with finfish. And so these are issues. All of these syndromes generally have gastrointestinal, and most of them have neurological symptoms also associated with them, which is how many of them came by their various names, such as paralytic, amnesic. Diuretic is one of those that's primarily gastrointestinal, not neurological. So paralytic shellfish poisoning is a common problem around the world, and particularly in the U.S. It's primarily been in the Northeast and along the West Coast. There are these saxitoxins, that's the toxin produced by the Alexandrium tamarense group. We have an Alexandrium organism here in Virginia that blooms regularly in the late summer. I'm going to talk about that in a little while. That is not in this same complex and is not known to produce saxitoxin. So right now, we may have an organism here that produces saxitoxin, and I'll talk a little bit more about that later. But for the most part, this paralytic shellfish poisoning has not been a problem in our area. But you may run across somebody who's traveled to an area where they may develop these symptoms. But typically, it's not a Virginia problem yet. But I'm saying yet because there may be something knocking on our doorstep with this. Often we see mortality in wildlife and sometimes mortality in humans. This is a very serious illness. There are even some cyanobacteria that can produce saxitoxins, but typically it's associated with these Alexandrium dinoflagellate species. Symptoms usually begin within minutes after ingestion, and this is usually shellfish consumption. It's a tingling and numbness, and even cooked shellfish will still carry saxitoxins. They are resistant to heat, so even cooking does not get rid of these toxins. Tingling, numbness in the mouth and lips, then the neck and face, and sometimes to the extremities. Respiratory difficulties and sometimes suffocation can result. Headache, dizziness, vomiting. So unfortunately, about 10% fatality rate associated with paralytic shellfish poisoning. So this is very serious. Or after 12 hours, many people will then recover and be better within a few days. Amnesic shellfish poisoning. This is production of domoic acid. Pseudonychia, that's a diatom, and this is one that's been a big problem along the U.S. West Coast. But there's an asterisk there because we do see Pseudonychia species here in Chesapeake Bay, and we need to understand a lot more about whether they produce this domoic acid toxin. Pseudonychia, this causes illness and mortality in marine mammals. You may have heard about seals and seabirds that will often succumb to this. There's, along the West Coast, been a lot of mortality associated with it. Again, you have the gastrointestinal and neurological symptoms, nausea, vomiting, abdominal cramps, and diarrhea, along with seizures occasionally. Disorientation and respiratory difficulty are much more common. Dizziness and headaches often associated with it. Fisheries on the West Coast were closed for a very long time because of the Pseudonychia bloom along the West Coast. Diuretic, this is the one that has fewer of the neurological symptoms, but clearly has diarrhea, nausea, vomiting. The gastrointestinal symptoms are very prevalent with Dinophysis species, which we also have in Chesapeake Bay, in the region, and in Prorocentrum. We do have lots of Prorocentrum species here, but so far we do not have evidence of toxin associated with those species, but this is an area that needs more research. Symptoms usually begin very soon after consumption of shellfish containing this toxin, oxalic acid. Neurotoxic shellfish poisoning, again I have highlighted here, Chatonella subsulsa is an organism that we see here in Chesapeake Bay, and we have detected the toxin brevetoxin, which is typically associated with the Karenia species, and Karenia brevis is the one that blooms in Florida. You may hear about red tides in Florida, and they're very concerned about that because of the brevetoxin, as well as the cyanobacterial exposures that occurred last year, I think it was. Lots of cyanobacterial problems in Florida. So Florida has had some serious issues with harmful algal blooms. Brevetoxin poisoning, neurotoxic shellfish poisoning is typically not fatal, but can make people very sick, especially those who may be immunocompromised. Again, the series of symptoms are very similar for many of these toxins. It may impact commercial and recreational fish species, so, and that's what they've commonly seen in Florida associated with this. We have detected very low levels of brevetoxin in mussels during Chattanooga subsalsa blooms, but those have been in areas that have already been closed to shellfishing. The rhapidophytes, the Chattanooga, heterosigma, and chloromorin, we see more and more of these, and we've seen them associated with large fish kills. And again, low levels of brevetoxin have been detected in some fish and some shellfish samples from these various blooms, but they're usually very far up in creeks and in areas where people are not harvesting shellfish. And this just shows you a map of where that is. We've observed this in the lower Chesapeake Bay area. Piquitera fish poisoning is not something that we've had to deal with in this area. It's typically a tropical syndrome. It's associated with tropical fish that are those top predator fish that Todd spoke about in the his pyramid. Usually snapper, grouper, those types of fish that are consumed in tropical areas. Ciguatera fish poisoning is very serious, but so far we haven't seen the organisms associated with this in our area. With the temperature changes, though, it's something that we always need to be aware of, a possibility, and of course with travelers. This is the VDH fact sheet that I believe Margaret and others worked on to draw up to kind of summarize what's in those previous slides to tell you about these various syndromes that are associated with the various toxins that can be produced by these HAB organisms. These are the action levels that have been used by the National Shellfish Sanitation Program, which is a national organization that works on drawing up regulations for these HAB toxins, as well as Vibrios and norovirus, other things as well, human health issues associated with shellfish. And so these are the action levels that have been set forth by that body. And our regional threshold, these are basically consulting with all of us who are on the HAB task force. We've been working on what levels we decide to increase our monitoring, sampling, and possibly go to the level of toxin analyses. This is the biotoxin contingency plan that has been drawn up by the Division of Shellfish Sanitation. So you can study this sometime at your leisure. It's pretty long and in-depth, but basically it just says what we do in a response to various levels of those organisms. And the ones we're most concerned about here are those ones that are emerging, the Dinophysis, the Pseudonychias, those organisms that we've seen here in our waters, but we don't really have a good understanding of their toxicity. They've mentioned before the Cochlodinium, Polycricoides, Cocklo, I'll probably say, and Alexandrium monolatum, which has been blooming almost annually since 2007. These are both of some concern to us. For Cochlodinium, we've had very heavy blooms in lower Chesapeake Bay for at least 40 years and probably longer. Harold Marshall at ODU has reported it for decades now. He's since retired. But he did a great job of keeping up on these blooms of Cochlodinium. And there have been reports from citizens in our area and even from people here working at VIMS. We have very heavy blooms here in the York River of irritation. Those with asthma have reported problems during the Cochlodinium blooms before. I remember a few years ago in the Hilton area of Newport News, there were reports of foul smells associated with Cochlodynium bloom, which can happen either during the bloom or when the bloom is dying off. Obviously, the biomass can smell pretty nasty. 2007, we had Alexandrium monolatum show up in a very large bloom. The last year it's been expanded, and Todd Egerton has reported very high levels now down in Virginia Beach, lower part of Hampton Roads, even into the James River. We're seeing this organism. It produces these very large, dense blooms here in the York River. Some of the people who have been working with this organism have experienced some relatively minor human health effects. Some aerosolization causes a problem, so now we use it in the hood in the laboratory. We've seen mortalities of experimental animals that have been receiving water from the York River during blooms, Rapana whelks and cow-nose rays. Shellfish growers in our area especially have reported mortality of very young oysters during the blooms. So we are watching this carefully because the human health effects are really not well characterized for this organism. So this is one of those that we've been wanting to get more data on and better understand the effects associated with exposure to Alexandrium monolatum. It typically blooms after the Cochlodynium bloom, and right now in the York River, we are just now starting to see Cochlodynium in the center part of the York River within the last few days. It looks like it's starting to bloom, so we'll be watching very carefully for this. Some VDH staff last year were exposed to Alexandrium during collecting some samples during the bloom and had some tingling, slightly stinging skin submerged during HAB sampling, so we're taking extra precautions this year for our sampling. So the groups most likely to be exposed are scientists, aquaculturists, those who are growing the oysters in the area, fishers, the boaters, and swimmers, clearly. This is one of those areas, like I said, we need additional information. Karen Hudson and Margaret worked on developing this fact sheet that we're hoping to have distributed now to the shellfish growers in our area so that they would be reporting if they do have any health effects associated with exposure to these blooms. Any of the blooms, whichever ones, but possibly, Cochlodynium and Alexandrium, if they do have any symptoms associated with it, they would hopefully be reporting those to the health department. A lot of people have been involved in the research that we've done over the years. Can't thank everybody enough. It's taken a village really to do all of the work that we've been doing. So thank you very much, and we'll take more questions at the end. There are extra slides in here for information about distribution of those various syndromes as well, that I've added on to the end of the presentation for your information. Okay?
Okay, thanks, Kim. And again, we'll hold our questions until the end of the session. So next up will be Anna Cologne. Anna, are you out there?
Yes, can you hear me?
I can. So Anna will be presenting notes from the field, epidemiology, investigations, and surveillance of health effects associated with Alexandrium monolatum algal blooms in the eastern region. And Anna is the Eastern Region Epidemiologist, and her office is located in Norfolk. Her area of responsibility is to ensure the delivery of epidemiologic program services in the 9 health districts of the region. She provides technical consultation and leads investigations, disease tracking, and control implementation activities, training, and conducts EPI-program quality assessments. Anna has served the Commonwealth for 28 years at local, regional positions within the Department of Health. She's very interested in every aspect of public health, especially emerging diseases, disease surveillance, and research methods. Anna enjoys outdoor activities such as hiking, bicycling, and kayaking, but not during HABs. So, whenever you're ready, Anna.
Thank you, Keith. Good afternoon, everyone. My main objective is to present an overview of our experience responding to complaints of health effects during a high bloom of Alexandrium monolatum in the eastern region, and this specifically happened in mid-September last year. Next. Next slides, please. But first, I'd like to provide you with a quick background on our experience in Eastern region with past investigations and activities regarding algae bloom. Monitoring of HABs in Virginia began in 1985, and the fish kills for which Listeria became well known began actually south of us in North Carolina, on a time where there were very little research conducted on this unusual algae. In 1997, over 50,000 fish died. It was a big impact on fish kills in a small area of the Chesapeake Bay from this toxic algae. And so press coverage of the event was like an explosion. Maryland was the first state from which people reported neurocognitive, respiratory, and other symptoms from environmental exposure to this algae. And so between 1997 and 2005, monitoring of harmful algae basically focused on this particular species. The role, as outlined by Margaret, of the health department, particularly at a local level has been involving alerting and educating the medical and the public regarding these algae blooms, and to report any situations of concern, particularly illness. The historical epidemiological role relied mostly during this time on passive surveillance, basically getting reports from individuals to the health department or from providers. And at this time, we were not set to conduct active surveillance as we do now using our enhanced surveillance capabilities. The primary message at that point, and I think it does continue to be, that when in doubt, stay away from the water, basically. And so specific to Alexandrium monilatum, epidemiologists, basically, our mindset has been always associated harmful algae bloom health effects with seafood consumption, as Dr. Reese pointed out, and not with human illness related to direct recreational water exposure. And so during the monitoring activities last year around September 2016, of the Virginia Department of Health and DEQ and the Virginia Institute of Applied Science and Old Dominion University, these partners identified significant algae bloom activity in the Chesapeake Bay and a number of their tributaries. Although this particular species is known to cause fish and shellfish mortality, it has never or has not been recognized and documented in the past as producing toxins of human health significance. And so we don't really have a correlation between cell count and causation of health effects, and which mechanism is involving in causing these health effects. It's actually not understood or identified. Next slide. And so we launched an epidemiological investigation once we heard about these illness concerns and exposures. Basically, these exposures occur in Gloucester Point, Yorktown, and James River during high counts of Alexandrium monilatum. Basically, also between end of August and mid-September is the period of time in which we circle around our investigation. The complaints were coming from, as pointed out before, basically from researchers and water monitoring staff, particularly 4 of them very recent, occurring after exposure to Alexandrium monilatum within a week, and 2 others that we decided to retrospectively look into potential exposures that happened in 2011 and 2012. So prior to these reports, we, like I indicated, our mindset is based on harmful algae bloom exposure due to seafood consumption, not specific to direct contact with water. So our approach on our typical basic epidemiological characterization of the problem was to identify who, what, where, when, and how. And we had many, many other questions from that because we were really going into unknown territories in terms of an epidemiological investigation. And so at that point, as a regional epidemiologist, I decided to take on the investigation and lead it, since basically it was the best way to coordinate among several jurisdictions and partners. Initial steps were basically identifying each of the people affected. I conducted several initial phone calls, conversations, and interviews, and we also did in-person interviews as well. In terms of findings, we had a total of 4 cases of concern. Again, we identify 2 and maybe other several historical identification of similar complaints, but most of these workers were not actively exposed or we were not able to contact, so we just concentrated on the 4 more recent exposures moving forward in our investigation. 3 or 4 of those reported predominantly a skin irritation type of sensation of heat, ranging from warmth to mild burning, and slight aching or stiffness on fingers, hands, and arms directly in an area that was exposed to the water. Overall pain was basically minimal, and these symptoms persisted after washing the area with soap and water. There were no visible changes in texture or color of the skin. For example, there were no eruptions, lesions, or pustules. In terms of the onset, basically it was within minutes. Within 5 to 10 minutes after exposure, the workers began having these sensations. And they lasted anywhere between 2 to 10 hours. To note, one specific case of the 4 reported a variety of skin, respiratory, airway type, and gastrointestinal signs. Of importance is to note that this person is a laboratorian who actually works directly with high concentration of harmful algae bloom water specimens in a very confined setting in a lab. And this person also provided a history of other signs and symptoms for many years. Actually, in our conversation, we were able to backtrack at least 8 years' worth of health issues when working with water specimens from a bloom, and not specifically Alexandrium monilatum. This person had also issues with working with other type of bloom species. Next. And so, like in any epidemiological investigation, we also face many challenges, particularly for this one, because everybody worked and resided in different jurisdictions. There was a high level of coordination required to conduct the investigation. And so that's one of the reasons why I took on the lead as regional epidemiologist. Plus, we were trying to figure out our way to conduct very effective case finding and active surveillance at that point, which was one of the challenges in terms of tracking and reporting, because harmful algae blooms, unlike the traditional reportable diseases and conditions that we handle every day, we really do not have systems to conduct active surveillance for specific situation addressing harmful algae bloom. So we utilize for this investigation our ESSENCE system, which is our system to monitor data that comes from acute care facilities like hospitals and urgent care practices, and that involve analyzing complaint data that we could effectively match and validate as one potentially caused by a harmful algae bloom exposure. And so we are conducting that part of active surveillance along with our HAB monitoring season of March 1st through October 31st. and paying special attention to the season peak of algae bloom, which is usually between May to September. And to note also, we have to work with CDC in our case definition to what is included as a potential human harmful algae bloom case. And that includes exposure, and meaning having exposure with signs and symptoms that are compatible to those health effects, and conducting, it does require conducting a full public health assessment, which is what we did in this case with Alexandrium monulatum. We also review the tool. It's a case report from HABs, that's the CDC official case report form, which we found in this investigation not to be user-friendly. So we did come up with our own work case form that it goes directly more into identification and characterization of that initial effect. And then further on, we will refine that further to match our case report form for HABs, so we can put it into the CDC system to be documented as well. And we also face, as usually we do with EPI investigations, participant recall and perception bias issues. And that usually is based on the person's own perception of risk and illness caused directly or indirectly by that particular exposure. So one of the challenges was to kind of like sweep around some other incidental information and concentrate on specifically the potential for the harmful algae bloom direct exposure. Next. And so we did run into some challenges, but at the end of the day, I think that we had a great starting point, particularly refining our approach to investigate these complaints, whether it's at an individual level or cluster. And since October 2016, we have been working to standardize our protocols to respond to these incidents and to conduct investigations effectively. We have validated queries in our essence syndromic surveillance system to actually pick what we could consider and feel comfortable that could be a good way to look at the data to characterize these symptoms. And like I mentioned, we develop a more user-friendly internal form to capture this information with every investigation that we conduct. And we have worked with partners within VDH and outside agencies like VIMS. We have been sharing our experience with our investigation and how we could increase surveillance in public areas to increase awareness too of this risk. And so that way we're hoping to gather more information and data regarding these blooms and potential health effects of particularly Alexandrium monulatum. And from an epidemiological perspective, there is always a need for more data to define trends, which can only be obtained by tracking and reporting occupational exposures. And so there is a need to also to raise more awareness and caution employees of this risk and provide and encourage the use of protective equipment to prevent exposures, because that's at the end of the day what we want to achieve. Next. And thank you everybody for your time.
Okay, thank you, Anna. Hold questions and move along to our next presentation, which is freshwater cyanobacteria and health effects. And this was presented by Amani Basayuni, who is a statistical analyst for the Division of Environmental Epidemiology Waterborne Hazard Control Program. She has over 6 years of clinical experience and over 3 years of public health experience. She received her MPH from the Virginia Commonwealth University with a focus on epidemiology. She is responsible for the QA, QC of the beach monitoring and harmful algal bloom program data, and a member of the Virginia Harmful Algal Bloom Task Force. her favorite public health quote is, "The major factors that brought health to mankind were epidemiology, sanitation, vaccination, refrigeration, and screen windows," by Richard Bland. So thank you. Imani, you're up.
Yep. Okay, this presentation focused mainly on cyanobacteria, toxins, and health effects. So as a brief overview, cyanobacteria or blue-green algae, it is a photosynthetic, single-celled, and found mainly in fresh water and some forms of salt water. It blooms when there is excessive nutrients such as phosphorus forming visible film or scum on the surface water. So there is what's known, most species are not toxic, but still many of them can produce cyanotoxins. So here I'm going just to mention a few of most common cyanotoxins, such as microcystin, cylindrospormosine, not sure if I pronounce it right or wrong, but I guess cylindrospormosine, yes, and anatoxin group and saxitoxin. Most common cyanobacteria species that has a capability to produce toxins. I can mention anapina, cyan, cylindrospormosis, and microcystis. And I know there is more, but it's even hard to pronounce. I apologize. Most common health effects, it can cause damage to the liver, it can affect the nervous system, it can affect the skin. Thankfully, in US, most acute health issues and deaths have been pets and livestock. So no really reported human health issue. So toxicity and health effect. Let's start with hepatotoxin. The main cyanotoxins is microcystin, deuterins, cylindrospormopsin, and the route of exposure will be through swallowing or ingesting contaminated water, or maybe accidental, as Dr. Rees mentioned before. Signs and symptoms could be elevated liver enzyme, which is known as alanine transaminase. That can cause hepatomegaly. Also, we can some gastroenteritis symptoms has been observed, like diarrhea, nausea, vomiting, abdominal pain, fever, malaise, headache. So the symptoms onset can be from minutes to hours, and this is also could be like confused by acute viral hepatitis or toxic hepatitis. Other toxicity is neurotoxins, and this is mainly can be by anatoxins A and saxitoxins. The route of exposure could be also swallowing contaminated water. Signs and symptoms could be as tremor, twitching, muscle cramps, motor weakness, paresthesia, cardiac or respiratory paralysis. The onset would be from minutes to hours too, and this is also could be similar as pesticide poisoning or other toxic poisoning. Also, this cyanotoxin can affect our skin, and the route of exposure could be like direct contact, and this is could be as itchy skin, red skin, can cause hives, skin blisterings, and rashes. Again, symptoms can be from minutes to hours, and differential diagnosis could be similar to allergic reactions. I found this really great diagram from EPA website. So it's summarized most of the human body and pet's health effect. So it shows that cyanotoxins can affect your brain, and this is through ingestion, and also can cause other digestive system health effect. Already mentioned that. Also through inhalational, we can receive respiratory issues like dry cough, sore throat. It could be also pneumonia, and sometimes it can reach shortness of breath. And also it can affect the neuro system. It can also make weakness, make a tingling sensation. In bed, mainly it affects the respiratory system. It can even cause respiratory paralysis. So for us also, created this is PDF. It summarized all the cyanotoxin and cyanobacteria genera, and also we summarize it by health effects, same as what I mentioned before, and we store this on our website under our HAB resources to be like a tool for epidemiologists and nursing staff. That's it. Thank you.
Okay, thank you. Kimball, go next. So next speaker is Paige Mordwine. Paige, are you out there?
I'm here.
Let me go ahead and turn off presentation here. All right, and then Paige Mordwine is going to be presenting on freshwater algal bloom case study and lessons learned. Paige is a Southwest Regional Epidemiologist. She's been with VDH for 22 years. Most recently, she was the District Epidemiologist for the River Health District for almost 10 years. And the bloom addressed in this presentation occurred during Paige's first week Regional Epidemiologist. So this was her first experience with an algal bloom. Her assigned task on this bloom was to help address the potential resource needs. So, Paige, anytime you're ready.
I'm ready, thank you. I'm going to discuss some of the assignments that I had for the algal bloom in Southwest Virginia. In February 2017, there was a freshwater algae bloom that was reported in a reservoir that was used recreationally for fishing and served as a raw water source for a water treatment plant that served approximately 37,000 people. And this is a popular recreational area. So a unified command was established, and it included local, regional, and state partners. And one of my assignments as a regional epidemiologist, since this bloom fell under the jurisdiction of one local epidemiologist, my assignment was to look at resource needs. And so for epidemiology support, I know Anna spoke about Essence and the surveillance conducted. So the two main issues that I looked at is surveillance and partner resource groups. And we utilized Essence for syndromic surveillance. And also through a partnership with Virginia Tech, we looked at social media monitoring, looking at Twitter and Instagram and some limited Facebook applications. And then with our partner resource groups, we involved Blue Ridge Poison Control Center, since the bloom fell in their area of support, and the Virginia Biocomplexity Institute at Virginia Tech, using their expertise for social media monitoring. And they have a number of computational epidemiologists and folks that do a lot of disease modeling, and that provided a great deal of assistance for this particular issue. So for our surveillance in Essence, we looked at 4 queries, and we divided them as they would be associated with symptoms into gastrointestinal, neurological, skin irritation, and exposures. And that's a list of the terms. If anyone else experiences that, you're welcome to use that particular list, and that seemed to work well for us. For our social media monitoring portion, some of the doctoral students at Virginia Biocomplexity Institute developed a tool called Chattergrabber, and it's a Twitter search method that is a social media data miner that was developed in Python, and it uses Google Docs as the interface. So it's a simplified access, and you don't have to learn any particular programming language or anything like that. It uses natural language processing so that you can filter content. And then nightly, the program will send to the subscribers for a particular issue CSV data, charts, maps, word clouds, animations, Instagram posts, and things like that. It will track hashtags, images, shared links, so it will pick up some things from Facebook, especially if people use multiple accounts and they're all linked. And there's another product that was developed by Virginia Bioinformatics and Biocomplexity Institute, and it's called EpiDash, and it's an online dashboard that will display all of the information from Chattergrabber in a user-friendly visual program. And all of this is open source software. So for Chattergrabber, it's very similar to Essence, but you qualify it slightly differently. So you look at each term that you're going to put in, and you put in your term. If there are any qualifiers that are associated with the term, you add that, and then exclusions. So if it was vomiting, we didn't really want to know about people who were vomiting because they ate too much. We didn't really want to know about people who were vomiting because they drank too much, or those types of things. So that would enabled us to narrow down the things that we were looking for. And when we were able to compare the findings from social media monitoring with Essence, we were able to get a very good picture of the things that were going on in the community and the concerns. Were people going to seek medical treatment, or were they just tweeting about issues? And that allowed us to develop some very targeted messaging as well. So this is a sample of some of the graphics that are provided for the social media monitoring. And you can look at the monitoring in different ways. You can look at just daily distribution of tweets based on certain terms. You can select key terms, or you can look at all of the terms. And then look at hourly distribution if there's a particular time that might coincide with a popular fishing time or a popular time for recreation, and people were visiting the area. So this allowed us to look at it from that perspective. And the information on Chattergrabber, there's a link that is a 4-hour workshop online that's available for people to train, and then the software is open source, and the link to utilize it is available on the right. Now our next partner with our resources was the Blue Ridge Poison Control Center, and they were an excellent source of information regarding exposures. They also provided subject matter expertise regarding medical issues and recommendations for care, and it aligned really well with the local community because there's already a link established with medical providers, especially emergency departments. They work closely with their poison control centers, so that link is already present. They were able to provide information through their call center and just ask that we provide incident information, situation reports, and talking points, and then maintain contact throughout so that we could better determine what the concerns were, if there were exposures that were being called in with a concern to local poison control, and we got a better idea of any medical providers that were seeing patients that might have contacted poison control. The contact information, the main poison control hotline is the 800 number, and then there are 3 poison control centers that cover Virginia, and their contact information is present for each of the 3, and then a map showing their coverage area. So Blue Ridge Poison Control covers most of the state of Virginia, and they certainly covered our area in far southwest Virginia. Thank you.
Thank you, Paige. So our next speaker back up again is Amani. Get your presentation up. We'll wrap up for this session.
Thank you. So this session is actually we're going to focus on HAB-related health effects report forms and the forms that Anna was talking about, the HAB initial screening forms that are created by VDH staff. So for CDC, which is also called One Health Harmful Algal Bloom System, so this is a form used to collect harmful algal bloom associated human cases, animal cases, and environmental data. So this form is composed of 6 pages that cover 6 parts. These 6 parts included general information, human exposure information, signs and symptoms of illness and health outcomes, clinical testing, supplemental information, and author and agency information. So this form considered more details than having initial screening form, and also all HAB need to be completed and then submitted to CDC online. So move to HAB initial health screening form. So this form developed after we thought like the OHAB is kind of more length and complicated form to use as initial screening. So this developed with collaboration with regional epidemiologists. It's considered as initial tool to report HAB-related illness. It is simple, but it still is a modified version of CDC. We try to cover the most important information that we needed. So the purpose of this initial form is just to help us to capture suspected HAB and have different exposure pathways and associated illness. And here is our form. It included 12 questions and it covered 4 sections. Those sections include demographic, include details on exposure, nature of exposure and location, symptom and sign, and associated illness. So it's still kind of OHAB, but in a brief way. So still there is a last part that we left it for the local staff, epidemiologists and nursing staff, to add more comments to the form if they think there is some information that is necessary to be submitted. So why we chose our HAB screening form versus CDC or HAB? OHAB form has been reviewed by some of Virginia HAB task force members, including epidemiologists, and this is where the recommendations. So as we said, OHAB included too many details to be considered as initial screening form, and also regional, local, and district epidemiologists usually receive many random calls related to water illness. Most of them are relevant. So OHAB form may not be useful tool to report all these events, since we said the epidemiologists, they receive many random calls. So we thought like we can't just go ahead and fill out OHAB form. So create singular initial form to report most of calls, and then we need to filter based on their association to HAB. After that, this is the step we're going to follow. Fill out OHAB if we think that necessary, if we think the exposure is really related to HAB, and then submit to CDC. Other things, we are working on develop an algorithm that allow ABIS to report all waterborne illness, including HAB, and this is a project ongoing. So we think we're going to use RedCap maybe to develop some kind of survey questions that help us or help the epidemiology and local staff to report all the waterborne illness issues. and then submit that form. So that would give us an opportunity to really filter and filter accordingly. So it's going to help in two ways, like report HAB and other waterborne illness. So if the exposure is a HAB related, then the decision will be like filling out the OHAB form and submit it to CDC. And then I'm going to take this as an opportunity to encourage all the ABS staff to request red cab access if they don't already have one. I expect most of the epidemiologists, maybe they already have an access to red cab. So again, just to repeat everything, easy. We think the purpose of creating this one form, including HAB and waterborne illness, that will be easy to report all suspected waterborne illness using one standard form and one database. It will be easy for DEE waterborne staff to track and filter submitted forms, and it helps in decision-making process to fill out and submit OHABs. So thank you.
Thank you. Okay, we'll have time maybe for a quick question before we go on the break. Anybody out there? Questions? Go ahead. Then we'll go ahead and take a break, and we'll start with the next session at 2:40. Okay, we're back, 2:40. So we get started with session 3. And so the next speaker will be Leah Caballo-Smith, and she'll provide our first session, first presentation of the session on harmful algal bloom sample collection protocols for recreational waters in Virginia. And Leah is the lab manager at the Phytoplankton Analysis Laboratory at Old Dominion University. She's a participating member of the Virginia Harmful Algal Bloom Task Force and has been with the Phytoplankton Lab at ODU for 4 years. And prior to that, she spent 14 years working with conservation and water quality issues. So,
Thank you. I was asked to give this presentation in order to provide field staff with guidelines that they could refer back to when sampling during a bloom event or other sampling needs. And I'm briefly going to discuss the supplies you'll need to bring with you, some basic safety measures you can take when sampling, and then I'll get into where and how to take the samples and what to do with them and why we're taking the samples and what I'm going to do with them once they arrive in my lab. And I'm following the format of our protocols that I think Margaret can supply you. It'll be on the website and in the supply kits. And so we recommend, basically, Margaret will be providing the regional field offices with a starter kit that will have your basic containers and sampling and shipping equipment. But we basically would expect you to have access to 500 milliliter plastic containers, some amber glass bottles, your Lugol's for preservation, and the field sheet that your office typically uses is fine. We don't need a special field sheet or a special shipping chain of command form. You'll have a pen and a Sharpie and your shipping cooler. Some basic safety measures. Of course, you would use whatever safety protocols your office recommends that you've been trained to do, but in general, when sampling for a HAB event for an algae bloom, you're going to want to wear gloves and possibly protective eyewear if you're near a surf zone or in a boat where there's splash. And I put some pictures up here of the two extremes of attire, flip-flops, beach wear, bare hands, versus full gear for the Syria event that occurred back in the 90s. And so you're going to want to do something in between. You're going to want to wear gloves and maybe boots or waders. And if you're in a boat during the bloom, stay out of the spray. And when you're entering the water, take a look around you. Make sure you have your field buddy. If not, somebody knows where you are. And if when you get to site, water conditions are unsafe, there's a rapid current or something, choose a different place or wait till conditions improve. And you're not going to want to let the bloom material come in contact with your skin, or you don't want to get it in your mouth. And if you do get it on your skin, wash your hands immediately. And one of the best ways to get a bloom is using one of these sticks with the clamp on the end that you can use that arm to collect the sample from the water without getting yourself wet. And you can kind of even stay out of the water. When you get to the site, you're going to want to take any information that you can from what you see when you get there. Is the bloom near a beach? Is it associated with some sort of culvert? Are there docks? Are people swimming? Is there a smell? Is there maybe some riprap that's separating things as some sort of barrier? Is it a marina? And so all that information can help people make decisions as to what might be going on. And then something else that's important, and I'm sure most of these offices have their own data sheet, but checking turbidity and Secchi depth, water temperature, you're going to want to get a good location of where you are, your lat long, the name of the body of water, the position that you're taking the sample. Are you doing it at the scum layer or subsurface or at the bottom? And where you collect the sample is important. You're going to generally take your sample just below the surface as far out in the bloom you can get. Most of you aren't going to be in a boat. You're going to be taking this from shore. So try not to get the sample, right where there's a lot of churned up sediment or mud. When you step into the water, take your sample maybe up from the opposite of the water flow, so you're not getting dirt and mud in your bottle. And you'll try to take that below the surface. About 1/2 meter is really good, but if you're not in that deep of water, do your best. And when there's a scum present on the surface of the water, we'd like a scum sample as well. But you don't want to take that scum sample right at the interface with the air. A lot of that material has already degraded, and that'll be hard for us to identify what we see. You're going to want to take that scum sample at the scum water interface. And if you're taking a sample because you have a mat on the substrate, you'll want to collect the water just above the bottom. We're going to be doing 2 types of sampling. You're going to be taking samples for taxonomic identification and cell counts or enumeration. And you'll be collecting a preserved sample, and we use that for quantification for counting the cells and for identifying the species. The live sample or unpreserved sample is very helpful for us to use to better identify certain types of cyanobacteria. And when you are collecting the preserved sample, you can collect that in a plastic bottle or a cubitainer that a lot of the offices have. And you're going to want to add some Lugol's that will be provided in that field kit. And a good rule of thumb is so that your preservative colors your water so that it resembles weak tea. And so I put a picture there of a very darkly stained sample and a very lightly stained sample, and right there in the middle is a good target color, and that's approximately 1 milliliter of Lugol to 1 milliliter of sample. So that would be 5 milliliters for a 500 milliliter bottle. And for the live sample, you would not add the preservative. Something that's really important, this helps us a lot in the lab when we open up the cooler, is to clearly label your bottles. And you're going to want to tell me if you've applied Lugol's or not, and then we know what to do with that bottle. And we can't always tell by smell, and also we don't always want to smell these bottles. And so I have to apologize, a lot of these labels are DEQ labels because that's just what I had saved on the counter. And so you see the bottles there to the right. That took us a few phone calls to figure out which bottles were preserved and which were live. So it's just easier for all of us if you write that directly on the label when you send it to us. And our second type of analysis we do is we're testing for toxins. And we do this to determine if there's a health exposure risk to the public. A lot of these sites, there's a lot of recreation activity, fishing, swimming, kayaking. You can see some of these, sometimes the visible bloom doesn't deter the public from using the water, so that's important. And you're going to want to assume when you're out collecting a sample, you see a bloom, if the bloom has a scum to it, or if you see a lot of dead fish nearby, go ahead and collect that toxin sample in addition to the enumeration taxonomy sample. And we generally test in the state for microcystins. And if the location that you are collecting the sample has a history of other types of blooms that you've had problems with, other types of toxins like cylindrospermoxin or saxitoxin, you're going to want to give the lab a call to make sure that that we have that you get the turnaround time you're looking for. And when you're collecting toxin sample system is a little bit different than your regular taxonomy sample. You're going to want to put, for microcystins or cylindrospermopsin, you're going to take about 250 milliliter in an amber glass bottle. And for saxitoxin or anatoxin, you'll take the same amount, but in the freshwater systems, you have to add a concentrated sample diluent before or during the collection to prevent assorbate loss of the toxin, and you do not do that for microcystins or cylindrospermopsin. And when you take those samples, you're going to want to clearly label what toxin you're looking for, or if you added a special treatment to that. And again, you can see the bottle to the left clearly says microcystins, and the bottle to the right doesn't have what they're looking for on it. And this was one of our biggest logistical issues with getting samples mailed to the lab, is making sure that you pack the shipping container in such a way that there's no leaking or breaking, but mostly leaking on the trucks. If it's UPS or Federal Express, they'll take the coolers right off, and then somebody's got to drive over to the distribution center and sign all kinds of papers, and people are mad at you because their trucks are full of water now. And so I've taken a number of pictures on how to kind of pack a cooler. So this picture here is best case scenario. This is really what you want things to look like. Everything is contained in the cooler in a sealed or tied off bag. And then your shipping sheet or your field sheet, your chain of custody form, whatever your office uses, is separate from that, and it's in its own Ziploc bag or whatever kind of thing you use to protect it. And it's pretty easy. You want to start out with your cooler, just line it with a garbage bag or whatever bag will fit the cooler that you're using, and then you can make sure your bottles are in their own bag that's placed into the liner bag in such a way to keep them from loosely floating in the meltwater, and that'll prevent the bottles from banging into each other and possibly breaking. And you're going to be putting ice or a freezer pack in your cooler. And when you're using ice, it's because that's all you have, go ahead and put a second bag inside the liner bag. Put the ice in there, then tie that bag shut tightly, because then you'll prevent the meltwater from dripping out of the cooler when the cooler's jostled or being handled by the shipping company. And the final step you can do is pack any loose areas with whatever you have on hand. Bubble wrap, packing peanuts, a lot of people just use newspaper, and that'll keep things from bouncing around and shipping and sticking around. And one of the reasons why we also like to keep the bottles of the samples separate from the ice is to prevent any accidental freezing of the cells, because that inhibits our ability to identify your HAB species or algae bloom species. And so I just wanted to say thank you for everybody for the time, and to our partners.
Thanks. Move along, and next presentation, I'll ask Margaret to come back and talk about recreational advisories for harmful algal blooms.
Thanks again, Keith. So, we are going to discuss the where, what, why, when, how, and who of recreational advisories. We're going to cover both the VDH recreational guidance for microcystin aeruginosa and our EPA draft guidance microcystin cylindrospermopsin guidelines. We're going to review some of the resources we think would be helpful for environmental staff and other district staff members when a HAB recreational advisory is necessary. So we'll start with the where. Where might a HAB recreational advisory be issued? First of all, Virginia developed a freshwater recreational advisory guidance in 2012 for cyanobacteria microcystis aeruginosa. This is a common blooming species in lakes, ponds, slow-flowing rivers. They can also tolerate the conditions of brackish rivers and marshes. So these are the types of water bodies where we might expect a bloom to occur, and thus HAB advisory for recreation be necessary. Of course, there would be a focus on public access areas where that exposure might occur. One of the things I think it's important to mention for environmental health staff who might be going out to assess the site is that wind or wave action in a water body can push HAB cells to the edge of a water body along the shoreline, while the remainder of the water body might just look fine and have no discoloration. In lakes and ponds, blooms or scums may accumulate near the dam. That's kind of the lowest point of the water body. So during HAB investigations, it's very important to fully characterize the extent of a bloom and to take samples in areas around and outside the visible edge of a bloom to help establish advisory extents and public notification. And so because blooms are common, it's important to consider what the exposure risk is. So again, boat ramps, swimming beaches, rivers where there's significant recreational activity, and where there is public access, of course, are areas where you might consider hosting if we needed to issue an advisory. Obviously, we are going to prioritize public waters and public access points because these are the areas believed to be associated with the greatest risk for exposure for the public. So what is a HAB recreational advisory? It's a formal notification to the public which is issued as a result of detection of harmful algal species or their toxins at levels which may pose a human health risk. It usually includes a press release and water body signage. And so what exactly do recreational activities do HAB advisories apply to? Well, it's pretty much any activity that may result in accidental ingestion, dermal exposure, or aspiration into the lungs. So obviously this would include swimming or wading, but it would also include the use of kayaks, stand-up paddle boards or SUPs, jet skis, any kind of a vessel that's likely to turn over, tubing, that kind of thing. Children and pets are in particular vulnerable to HAB toxins because even a small amount can cause illness or death. Children are also more likely to swallow water while swimming, and dogs are particularly vulnerable because they consume water at a greater volume per body weight than humans do. And pets may continue to ingest toxins once they come out of the water by licking their coats following exposure. So what are Virginia's HAB recreational advisories based on? They incorporate both toxin concentration and cell concentration for microcystin and microcystis aeruginosa. These levels were developed using methodologies which consider the toxin concentration, exposure modes, and risk of health effects determined by the exposure level. HAB cells are not going to be uniformly distributed throughout a water body. Therefore, cell and toxin concentration thresholds can provide flexibility in the application of the advisory. Also, if you happen to be in the process of sampling during the initial stages of a bloom investigation versus when a bloom is subsiding, you may have more toxin or less toxin in the water. You may see more cells or less cells. As cells die, their cells will lyse, releasing their toxin contents. And for toxin concentration guidance value, in our guidance it is 6 micrograms per liter or 6 parts per billion. Ingestion is the most complete exposure pathway for this toxin, and Virginia's HAB toxin concentration guidance value was developed using the WHO's recommended tolerable daily intake, or TDI value, 0.04 micrograms per kilogram per day, with the body weight of a child, 15 kilograms, with an ingestion rate of 0.1 liters per day, and assuming an hour of swimming per day. And so when you look at guidance values across the states, you're going to see all kinds of different values because people have used different assumptions. And we believe in Virginia we use relatively conservative assumptions based on our most at-risk population. So again, the guidance value equates to 6 micrograms per liter, 6 parts per billion, and this is not to be exceeded by any sample in a day. The cell concentration guidance value was also based on WHO guidelines where dermal effects begin around 5,000 cells per milliliter, with the majority of health effects being reported between 20 and 100,000 cells per milliliter. The WHO determined that there was insufficient evidence available to evaluate a benchmark health risk from inhalation exposure. So this is just a diagram of Virginia's freshwater recreational advisory action levels, and we have 3 of them for which we would issue, we would either elevate our monitoring and or issue a public notification for an advisory. So at the lowest action value level at the very top in green, we have elevated counts. And so we have over 5,000 cells per milliliter and not more than 20,000 cells per milliliter. We increase our sampling to biweekly when we get to that cell count, and we notify the local health district. At the second level, where we have more than 20,000 cells per milliliter but less than 100,000 cells per milliliter, that is when we are at our intermediate action level, and we would issue a public notification that we have detected the presence of harmful algal blooms, and we would then move to weekly sampling. At the advanced action level in red, where we have detected over 100,000 cells per milliliter, or we have detected toxin, microcystin greater than 6 micrograms per liter, we would move to immediate public notification to avoid all recreational water contact where the bloom may be present, and we would just continue with weekly sampling to monitor the bloom and the bloom extent. We also have at this advanced level, because of the cell concentration, we would expect potentially there to be scum present. And when there is scum present, just by observation, you may also issue an advisory just based on the observation of scum. This was included as sort of an extra level of protection so that if we had a very high recreational use area and there was scum present, all of the environmental evidence was suggesting this was a bloom, that the health department could take the discretion to issue a notification based on this guidance, since scum certainly is a high indication that you have a HAB going on. Microcystin is the most commonly detected cyanobacteria toxin. It is produced, again, by Microcystis aeruginosa, as well as many other cyanobacteria. We utilize microcystin as a screening tool for our HAB events. So with that said, there are many cyanobacteria species that have been detected in Virginia's freshwaters, and several can produce multiple toxins. So depending on species and their counts, additional toxin assays may be considered during HAB events by the HAB task force in our labs that we work with. Now for the why. Why does VDH issue HAB recreational advisories? Well, first of all, to prevent HAB-related health effects by limiting or preventing exposure to the bloom. Secondly, in the Code of Virginia, there is a section on closing of waters for toxic substances that we may issue on an emergency basis under the authority of the State Health Commissioner. It's worth noting that when it comes to private water bodies, such as when you have a subdivision and they have a public area with a pond or a lake and it's under operation by an HOA, it is perfectly reasonable for them to issue their own advisory for their own water body. Also, when you are working with other agencies that have property and can limit access, for example, at DCR parks where they have had bloom events, they can issue the advisory because they can control the access to the water body. They close their gates. They post using our signs. So it is not uncommon to work collaboratively with other agencies to issue advisories. So the when should HAB recreational advisories be issued? They should be issued when we have confirmation of HAB species counts elevated above 20,000 cells per milliliter, and when we have microcystin toxin levels above our threshold of 6 parts per billion. This is something that requires lab confirmation. And again, if we have scum present on a recreational water surface, we could also issue an advisory. And then here's just some lovely scum pictures. So how about how are HAB advisories issued and lifted? There are 4 basic steps to issuing and lifting an advisory. First, you have your HAB investigation, which includes sampling and establishing the bloom extent. Second, you have lab analysis to confirm HAB presence, HAB species identification, enumeration, and toxin concentration, where you have scum. And then you have interpretation of lab results, which is then followed by a DEE recommendation to the local health district. That recommendation may also be accompanied with a request for assistance from local staff, such as EHS staff, to support bloom monitoring. Step 4, because all response is local, the health district will need to consider DEE's recommendation on issuing advisory, and at the health director's discretion, the health district will issue the advisory. DEE staff facilitates public information officers and environmental health staff to develop the press release, as well as posting to the algal bloom map, providing outreach materials, etc. And then to lift an advisory, there should be 2 consecutive samples less than 20,000 cells per milliliter, and samples should have toxin concentrations less than 6 micrograms per liter. When that is achieved, DEE would recommend lifting the advisory, and local staff would work to draft the press release and remove water body signage. Again, this is with the assistance of DEE if necessary. It should be said that if you're still at that low action level where you're between you're above 5,000 but below 20,000 cells per milliliter, you would still continue with biweekly monitoring until those cell counts were reduced below 5,000 cells per milliliter. And so again, who issues and lifts HAB recreational advisories? Unless the affected water body crosses multiple health regions, advisories are issued at the discretion of the local health district by the health district. All response is local. Moving on kind of into who are we trying to target with our HAB messaging? Most likely the users of the water body are going to be local residents. However, large water bodies with beach-like areas may attract tourists, so a combination of public messaging is important to consider. But of course, point of access signage is always recommended. Great places for point of access signage would include boat ramps, public fishing docks, anywhere that you can have permission to post a sign. Also, if you're in an area that has a lot of recreational use, and you have recreational excursion companies like the tubing companies or fishing or what have you, it would be a good idea to assemble a list of these companies and be able to notify them if a HAB does occur. That could facilitate your notification process. And then in addition to press releases, other forms of media such as social media, radio, local newspapers, it may actually be a better option to consider these in your area if you're trying to target a particular group. And so these recreational excursion companies who are out all day, they might respond better to something like Facebook or Twitter or something like that. So So depending on the scope and scale of an event, as well as the local knowledge of health district staff, it may be worthwhile to notify residents along the affected water body. So these would be landowners, farmers who might have livestock with access to the water body, local veterinarians, schools, medical providers, hospitals, and the Poison Control Center, like Paige mentioned earlier. So the question that we always get with harmful algal blooms is it safe to fish in a water body with a freshwater HAB advisory? And the statement is that yes, it is considered safe to consume fish fillets harvested from a water body under a HAB advisory, providing fish are properly cleaned, including the removal of all organs and skin, and cooked to proper temperature. So removing that viscera is really important. The fillets are not supposed to be absorbing any toxins. It's supposed to metabolize out, and so that viscera that you're removing contains any toxin that might be in the fish. There are some precautions to keep in mind. Never harvest fish if there are dead or dying animals present. Protect skin from exposure to the HAB water body, and wash skin and surfaces used for cleaning the fish thoroughly with soapy water. There has been a growing body of research which indicates that cyanotoxins such as microcystin can accumulate within the food web. There are also severely cyanotoxin impacted waterways where fish tissue analysis indicates that levels exceed safe consumption, but this really hasn't been translated yet into something like a meaningful guidance with respect to public health. And so we, of course, will continue monitoring the research that comes out of the academic community and basing decisions within the task force program on that. All of the information I've been presenting is contained within our 2012 VDH recreational guidance for microcystin and Microcystis aeruginosa. That document is available on our website. EPA issued a draft guidance for 2 cyanobacteria toxins last year for microcystin and cylindrospermopsin. Virginia's current guidance for microcystins is slightly above the EPA guidance, 4 versus our 6. And Virginia does not currently have a guidance threshold for cylindrospermopsin. Once EPA finalizes their guidance values, VDA would intend to adopt the EPA guidelines. So once they do that, we will be making an adjustment of our guidance. So I know some of you out there are probably thinking, there's one last what that she hasn't talked about. What about drinking water? When is she going to talk about drinking water? So given that this is a presentation on recreational advisories and not drinking water advisories, I still would be remiss if I didn't at least briefly discuss the potential impacts of HABs on drinking water reservoirs. Cyanotoxins are not currently regulated by the EPA. Drinking water plants are not required to screen for cyanotoxins in source or finished water. That said, EPA did issue in 2015 advisory thresholds for drinking water, finished drinking water for 2 cyanobacteria toxins, microcystin and cylindrospermopsin. This 10-day health advisory may be applied at levels protective for 2 population groups. It includes infants and children younger than 6, and adults and children 6 years and older. So just to reiterate from our earlier presentation, we discussed the roles and responsibilities of the Office of Drinking Water, that they coordinate HAB investigations with the HAB task force. Their role includes working with public utilities in the development of source water protection plans, and they have developed a draft ODW HAB response plan for drinking water. They coordinate with and provide guidance to public utilities for monitoring source and finished drinking water when HABs are detected in reservoirs, especially when they're detected near intakes. They would also work with public utilities to issue drinking water advisories. when 2 or more drinking water samples exceed the 10-day health threshold for either of the cyanotoxin noted on this slide. ODW would utilize the lower level of the 2 options in order to be protective of all populations in a community. So this is just something to really take home, is that it's really critical during a HAB event or investigation to identify whether a water body is a drinking water reservoir, and if so, to coordinate with ODW early on. Obviously, the concerns for drinking water safety will far outweigh the concerns with respect to recreation use. So let's move on into a few resources we think you guys will find helpful. This is a process communication flowchart for HAB events. It's meant to serve as a job aid for health district staff who might be involved in that coordination. It describes overall the course of events from start to finish of a HAB, the coordination expected of DEE, task force, and local health district staff members. So that's something we've got on our website and in our toolkit. We've also got template advisories, so press releases for issuing the advisory. We've also got one for lifting an advisory, and we are more than happy to help districts draft these for any particular event. We also, at the recommendation of our epidemiologists, developed some universal talking points which staff may find useful with putting messaging out during HAB events. My particular favorites include: most algal blooms are harmless, some algae can produce toxins, when in doubt, stay out, and to wash exposed skin thoroughly with water, along with the possible health effects symptoms, and that children and pets are the most vulnerable to HAB toxins. So pick a few that you like and memorize them. So this is a little bit repetitive, but again, we do have cyanobacteria brochures. We have tons in print, so we can ship them to you, or you can download and print them off PDF. We have our algal bloom map, where we will post the results of our bloom investigations, and we also can develop those feature pages when we have significant events that we want to provide a place for the public to go to find more information. And we can also do frequently asked questions in association with a bloom event. Now, I already showed this to you once before, but just want to remind you, we do have that HAB task force hotline, 24/7 operation. It's primarily meant for HAB-related human health effects, and then we have our online HAB report form for blooms and fish kills. Signage. So we have on our left a bloom awareness sign. This can be placed at public access points where we've had bloom events occur, and it may increase reporting if people see the sign and then they make that connection between the water and the sign, and maybe they call the hotline or they report on our report form. The sign in the middle goes along with our intermediate advisory guidance, so that when those bloom counts are between 20,000 cells and 100,000 cells per milliliter, it has messaging to avoid or reduce recreational activity in the water body. The sign on the far right that is red, so warning is very scary, is our advanced level recreational advisory sign. It recommends that the public avoid all contact with the water, and we use that when we have cell counts over 100,000 cells per milliliter or toxin concentrations are greater than 6 parts per billion. Both of these advisory signs, the one in the middle and on the right, they contain that public health messaging on exposure, what to do if exposed, and to seek medical or veterinary help for pets if you're exposed and if you're concerned about your health effects that you might experience. And because there is always that question of whether or not it is safe to fish in an area that has a HAB, both of these signs contain messaging related to the proper cleaning and preparation of fish that are harvested from a HAB water body. Again, those great kits that Leah had mentioned, we have been preparing these. They are reusable. We can replenish the contents. So as you submit samples and send them to our lab, the lab can ship them back, and we can continue to repopulate the contents. We intend for these kits to be used by local health staff, environmental health staff, to support HAB monitoring events that occur in your district. And just one last thank you to all of you out there in Polycom land for your participation, and thanks again to our wonderful DEQ, ODU, and BIMS task force responders to supporting us during our HAB events. Thank you.
Okay, so that's the end of this session. So, if there anyone that has any questions, we can go to those now.
We have a question.
Okay, go ahead.
Those HAB sampling kits that you guys just described, are they on their way out to the health districts, or have they already been sent out?
No, we just got the preservative we needed, and so we're going to be putting those together, putting in an instruction sheet, the sampling protocol we had talked about, and we're going to get at least one out to each health region, probably over the next few weeks.
Thank you.
Welcome.
And what would someone do if they have an event before the kit's in hand? Is there any guidance for that?
Oh, I guess we would. I guess the kits aren't really intended for our environmental health staff to be primary responders. You know, they're part of the task force, but they're sort of secondary. They're backup. So DEQ will always be our primary response group, and we do find, however, in some areas of the state where it can be difficult to get to sites, or if they've run out of particular materials, having that backup can be really helpful. Sometimes environmental health staff are located much closer to one of our HAB sites than a DEQ staff member is located.
And one more on the kits. With the collection guidance, will there be anything added in there as a recap for guidance for how to collect and any of that, a guidance document?
Right, so in addition to Leah's SOP that she just talked about, we're probably also thinking of doing a YouTube video. We thought that might be a good way, a visual, talk through to make sure that you're doing it right. Packing that cooler seems to be one of the key elements to making sure we get our samples to the lab in good condition. So that was one thing that we had planned to do.
Any other questions? Okay, hearing none, we can move on to our final session. And for that, we'll go ahead and ask Amani to come up and give her presentation on an overview of HAB Toolkit resources.
Okay, so for this presentation, it's going to be mainly like a screenshot. I hope if we have like a Wi-Fi, it'll be more like interacting presentation. But I'm going just to give you a tool of our Harmful Algal Bloom website. First all you need to type is harmfulalgalva.com, and that will take you to the main web page where the HAB map is there with recent sample results that Margaret has already talked about. So you can open the map either by click to this small picture, or the rectangle picture, the small pictures on the top, or to the tab on the left side that also mentioned Algal Bloom Surveillance Map. So on this page also we have other important tabs. So our new tab is the HAB resources, which is also served as a toolkit, and this will be our focus for today's presentation. Also, you can see the cyanobacteria tab, and this will take you to the main web page of cyanobacteria, where you can find all the information and needed resources. Then we have the HAB task force. Also, this is included all the definition about the HAB task force group and their responsibility and their role. And finally, you can see what are harmful algal. This is like a Q&A web page. So move on. This is how you see our map surveillance results with most current samples results. So if you click on any of these circles, that's colored circles, so what you can see, you see all the details about the site or the body, the water that has HAB. Maybe it's not HAB, maybe it's just algal bloom. So you see all the details about the species, the sample date, if the species produce toxins, and if these toxins exceed the safe level. Additionally, you can see information about if there is any advisory has been issued or warning signs. So our main focus today is HAB resources, also act as a toolkit. So this has been really created recently, and also it's within the HAB Harmful Algal Bloom VA.com. So it contains all the necessary HAB web pages and resources that we think environmental specialists and other health staff might need. It is very easy to access. So there is two ways to access this HAB resource web page. Either, as I mentioned before, by go to the main page and click the HAB resources, or through our main VDH website and click on the newsroom and then to the toolkit. This will take directly to our, under the toolkit you see Harmful Algal Bloom web page or tab. That will take you immediately to the HAB resources web page. And this is, we try to put everything in one page that consists of two columns. The column to the left briefly describe the corresponding link to the right. So you know when you go to the web page exactly what you're looking for and what is this exactly, what this link will be like, what is the description of this link. So personally, I thought this is like really very great invention, because when I started doing this job, I had really difficult time to navigate through our webpage to find all the resources that I'm looking for. So also you can download it as a PDF format on the top to just keep it as a reference. I'm not sure, I don't think it's, yeah, it's not bad, this is from my drive. So this web page is included all these resources divided by specialty. So we thought the first, the top part will be including all the web pages and surveillance map and general information for general public or whoever wanted to find any general information. The second part will be mainly focused on epidemiology, resources and information, and this is included most of our tools that epidemiologists might need it. And the last part will be just resources for environmental health specialists. So I guess this is a toolkit. It also might help us to remodel our web page that me and Margaret were thinking about to do soon. And this is definitely will not affect the HAB resources web page, since we're going to update each link that if we change the address for each link, for any link. So it would be great also to know your thoughts or any ideas, or whoever trying to visit our web page and just notice some kind of difficulties or problem, we'll welcome to just give us your feedback. Thank you.
Next slide. And we'll do one last recap. Cover our learning objectives. Go to final questions. Okay, so based on our learning objective number 1, which was the staff will be able to explain their roles during the HAB event. So for epidemiologists and nursing staff, they would need to know how to conduct human illness surveillance and epi interviews for suspected HAB-related illness. Submitting HAB health effects screening forms to the Division of Environmental Epidemiology, and coordinating outreach for HAB-associated event information with medical providers, hospitals, poison control centers, and others as necessary. And for environmental health staff, we would support HAB investigations by facilitating sample collections when requested, coordinates with the health director and the PIO to issue and lift recreational advisories and to post signage, and coordinate outreach and press releases for HAB-associated events information with the PIO and Division of Environmental Epidemiology. And then public information officers. We would support HAB investigations by coordinating consistent messaging to the public. We would do press releases for advisories. We coordinate media interviews with staff and subject matter experts as necessary. And then with learning objective number 2, to identify the characteristics of algal blooms and health effects which are possible. They usually occur during the summer in tidal rivers in the Chesapeake Bay or in freshwater lakes. They HABs can be harmful to public health when it produces irritating or toxic compounds. And exposure to HABs may occur by several modes. Consumption of fish or shellfish, contaminated drinking water, or possibly dietary supplements, by dermal exposure as a result of recreational or occupational activities, or possibly cosmetics. Respiratory, via aerosolized toxins or accidental aspiration when recreating, and then medically via hemodialysis. And health effects are usually caused by neurotoxins, hepatotoxins, or dermatoxins, which can produce symptoms within minutes to hours, and may include twitching muscles or motor weakness, gastroenteritis, like diarrhea, vomiting, nausea, and abdominal pain, and skin rash, stinging, and tingling and blisters. The learning objective number 3, when in doubt, stay out. Never swim in water that's discolored, has an odor, or if there's dead fish or animals present. And if you get algae on your skin, rinse it well with clean water, and if the symptoms of algae exposure symptoms from harmful algae exposure can include upset stomach, nausea, vomiting, diarrhea, skin rash, tingling, burning, and coughing. And children and pets are most vulnerable because they are more likely to swallow the water, and even a small amount of water can cause illness. So if you have health concerns from algal exposure, contact your medical provider. And learning objective number 4, report suspected health effects of harmful algal blooms to the HAB hotline. And for more information and to report blooms online, use www.harmfulalgalva.com. And we'd like to acknowledge this group of presenters and others that supported, including a nod to our Harmful Algal Bloom Task Force partners in the Office of Drinking Water, the Department of Environmental Quality, and the Virginia Marine Resources Commission. And here are our VDH HAB contacts. So with the Division of Environmental Epidemiology, Margaret Smyko, Waterborne Hazards Program Coordinator, Amani Vaisiuni, Statistical Analyst, and for Division of Shellfish Sanitation, Todd Edgerton, Marine Science Supervisor. So again, thank you to everyone there. And again, your feedback's important, so please fill out the course evaluation. And if you haven't registered already, please do that. And we'll go to final questions.
We had one additional question here about the harmful algal bloom signs. Is there any plan to get some of those large metal signs made for any of the districts or health regions?
Well, we've got better than metal. We have corrugated plastic. We have 2 each of the attention and warning signs. They're going to go out to the regions with those sampling kits. That's the plan. Those the signs we've got, they're like 16 by 20. They're kind of like your realtor sign size, and they come with the little metal foot peg to just stick in the ground. So, and they can also be affixed to other substrates as well.
Thank you.
You're welcome.
Any other questions? No, well, I have one. Are there any other trainings planned for harmful algal blooms?
Well, that depends on the feedback we receive. We could consider doing a HAB 102. We could consider working with ODW since they've got their new draft guidance coming out. Something like a partnership with them would be interesting for drinking water. Those are some of the ideas that I had. We're interested to hear what everybody else thinks.
And are you going to send out a link to how they would access the recording of this?
Yes, so if you registered and train, I can get your email address and I can send you a follow-up to the location of where that link will be posted.
Are there any other questions? If not, do you have anything else to add?
Thank you so much for joining
I'd like
us.
to thank everyone there for participating, and please fill out the evaluations. Thanks again.
Thank you.
Thanks, everybody. See you later.
The conference is about to end.